Yesterday we were adding and subtracting fractions, and we found out we needed, just like regular fractions, a common denominator. Same thing in part question number 3, but now you just have more fractions. So now you have to get a common denominator with each of them. So in A, if we rewrite and leave space, alright, there's lots of space. I'll switch colors here. Looking at the numbers, now we have 2, we have 4, and we have 3. If those were your numbers, what would you make your lowest common denominator? Right, you need, for the numbers you need a 12, so we're going to have 6 and 6 here. We're going to have 3 and 3 here, and you would have 4 and 4 here. And then you're looking at your variables, you need an a squared in all of them. This one doesn't have it at all, so this one needs a squared and a squared. This one has it already, but this one's missing an a and an a. That will give us 12a squared as a common denominator for all 3 of those. Then each one individually, this will be 30a squared minus 9 plus 8a. And of course, this right now is all grouped together. Anything adding and subtracting, that groups it all together, so unless there is something identical to that, we can't simplify any more than this. And of course, your textbook also goes and lists that the non-permissible value is that a can't equal 0. Part B, same thing. Going to rewrite it. By adding a fair bit of space. Switch colors. And we're going to multiply by 1 to get a common denominator. So looking at the numbers, 3, 8, and 6. And you see that the lowest common denominator would be 24. So this one's going to need a 3 and a 3, an 8 and an 8, and a 4 and a 4. And also, I'm going to add brackets because wherever I have binomials, right, adding and subtracting, that will group those things together. Now for my variables, I have a z squared, a z, and a z, so we need a z squared. This one needs a z, and this one needs a z squared. That will get me a common denominator of 24z squared. And then each one individually, and I'm going to do each one individually and just put it in brackets temporarily. So when I distribute this 3, I would get 6z plus 3. This one, when I distribute that 8z, I will get 32z squared minus 32z. And finally, when I distribute the 4z squared, I'm going to get 32z squared minus 4z cubed. Now I kept them in brackets just so that I could see that I did all 3 of them separately, but it's also extremely important with the brackets when you're subtracting. Okay? When you're adding, the brackets actually don't matter. But when you're subtracting, this negative is going to go to both of those. You see that you have some like terms. Common denominator, we still have 24z squared on the bottom. Okay? Usually when you write the final answer, you would start with your highest power. So when I distribute this negative, do you see that you will get a 4z z cubed. Positive 4z cubed with that negative distributed. Now with my z squareds, which I'm going to underline, there's a z squared there and a z squared there. Do you see that they're going to go away? 32z squareds minus 32z squared, that's going to go away completely. With my z's, which I'm going to underline here in purple, these are like terms, I'm going to get negative 26z, and in my numbers I have a plus 3. And of course the textbook also writes down that the non-permissible value, that z can't equal 0. So the ideas of adding and subtracting fractions are the same whether we're using variables or not. Where things get a little bit tricky or difficult is we've got to do all of our algebra rules. So adding brackets to hold things temporarily is a good thing, especially when they're subtracting signs, because those are easy places to make small algebraic errors. And I already gave you the questions, but I'll give you them again. 9